Hello and welcome to this Edexcel Further Maths Statistics 1 video calculating probabilities from the negative binomial distribution. This is a reminder of the definition of the negative binomial distribution. The probability function probability x equals a particular outcome x is given at the top of the slide, and remember that the random variable x represents the number of independent trials necessary in order to achieve R successes. Therefore, the negative binomial distribution has two parameters, p and r, and the possible values for the random variable x start at r. We must have at least r trials if we're looking for r successes. Remember that you may be unfamiliar with this notation and more familiar with the NCR notation on your calculator, and these two notations are equivalent to each other. And if you think about what x minus 1 c r minus 1 represents, it is giving us the number of different ways in which we can achieve r minus 1 successes in the first x minus 1 trials. And clearly there must be r minus 1 successes in the first x minus 1 trials in order that the final rth success occurs on the xth trial. So looking at a simple example here, we want to find the probability that the fifth head occurs on the 10th flip of a coin. And that means that we must have a minimum of 5 flips so that the fifth head occurs on the 10th flip of the coin. X would represent the number of flips necessary in order to obtain the fifth head. The parameter p would represent the probability of a success, the probability of obtaining a head, which is a half, and r, the number of heads, the number of successes in total that we require, is 5. And this slide just identifies both the random variable in more detail and p and r, the two parameters involved. And you may at this point just like to pause the video and go back and double check on the probability function for the negative binomial distribution before I show you how to obtain the answer. What is required here is the probability that x equals 10. That we need 10 trials before we achieve the fifth head, and that would mean that we require 4 heads in the first 9 trials, and the number of ways in which that can happen is 9c4, and then we are going to require 5 heads altogether, and therefore also 5 tails. And of these 5 heads here, 4 will occur in the first 9 flips, and the 5th will occur on the 10th flip. And this is written using the exact notation in the probability function. And if you evaluate that, and remember 9CR on the calculator is probably the way you're going to go there, we get a probability of 0.123. And this second example is again one we looked at in the previous video, and we are given certain information. We were told to assume, and I will tell you again, that the probability of a person being found on a street in Stoke-on-Trent who attended the last home game is 0.4, and clearly we want to find 10 people, and x is the random variable, how many people we need to ask before we find the 10th person who attended the last home game. And this summarises the information that we were given for that example. And in this particular example, p equals 0.4 is something that we are told we can assume. So it's a modelling assumption that we need to make in order to try and find a value for the probability that the 20th person is the 10th person found who attended the last home game. So in order to find a value using that model for there being 20 trials before we find the 10th person, we would need quite clearly and intuitively, in the first 19 people that were asked, in the first 19 trials, we would need to have found 9 people who attended the game, and then we would need altogether 10 successes, 9 people found in the first 19 and the 10th found on the 20th person that we asked, the 20th trial, and we would then need 20 minus 10, or 10 failures, 10 people who did not attend the last home game. And evaluating that, and remember that the question posed is fairly straightforward. The assumption we've had to make is that the probability a person randomly selected from a street in Stoke-on-Trent attended the last home game is 0.4. And that's the end of this video. The next video will look at the mean and variance of the negative binomial distribution.